Hello, this is Shakil Ahmed. In this tutorial, we will learn how to analyze data with survey weights. So, first of all, we need to know what is survey weights and why we use survey weight. So, basically, uh, when we have a simple random sampling, we don't need to adjust for survey weights as we are giving equal weights to different sampled units. Different units which are selected in sample, we are just giving equal weights. But when we have some type of complex survey design, here complex means we have or different sampling mechanism on different stages. For example, we have a multi-stage sampling and apart from this we have for example stratified population. For example, we have a stratified population and within strata we are applying a multi-stage sampling. Then the sampling strategy become complex, the sampling design become complex. For example, if we have a multi-waste stratification, then we are stratifying the population with respect to different characteristics. Then we are we are basically dividing population into different small groups, and the representation from the small groups become crucial, and we need to assign different units belonging to different proportions, different subpopulations. So in such type of analysis we need to adjust for survey weight. I am giving a link with in description of this video. If you want to learn more about survey weight and why we need survey weight and in which situation we need survey weight and which situation we don't need survey weight, you can see the complete details. So for now, for analyzing survey weighted data, I will just show how we can obtain descriptive statistics for survey weighted data in this tutorial. We need to install different packages like the survey package and gtools and remotes, and this is a new package that is available on GitHub. Survey EP, EPMICS, that is used for epidemiological to produce epidemiological parameters like proportions, prevalence, incidence, and such type of things. And uh, we just call these packages, and then we need to adjust survey design function that is called survey design. And in survey design, we need ID, that is basically survey design primary sampling unit, that is basically identity for some different primary sampling units. For example, if we have if we are selecting different counties within district of United States, then the county ID will be the primary sampling unit ID for primary sampling unit, and we are giving weights that is already calculated within survey data, and this is converted in for 2 years as we are integrating survey for 7 consecutive surveys conducted for each 2 year. Then we need to divide the survey weight, given survey weight, by the 7 as we are uh, accumulating 7 survey years, different survey cycles. And then stratification variable, that is also mentioned in survey data, uh, through which stratification was done. And these three variables you need to insert, and nest is equal to true means the data is nested within primary sampling units, and primary survey lonely primary survey sampling units that are adjusted, that will be adjusted, and your data frame is df. So let's start in R. I have already called these packages, and you can just call these packages, and I will recall my data frame read.csv. I don't know where I have saved my data, so instead of giving this directory to after for obtaining the data, you just call this file dot choose, then you will get wherever your data is. You can just browse. My data is, I think, in download, and then as new file, as I have saved the recorded and cleaned data that is obtained from National Health and Nutrition and Examination Survey, right? So I'm using this data frame, and you can just see the dimension of data again, and then you can see different variables. uh, First few observations, and then we can set the survey design function that I have already discussed, and this is the survey design function. All these variables are in my data set, like is the primary sampling unit indicator and the weight variable and the stratification variable. So you can just run this command and you will get the survey design function, and that is required for analysis, for further analysis when you are computing average, you are computing standard deviation, you are computing different proportion, then you need to use this survey design function. So basically you are setting your survey design in start, and whenever you use this survey design function, the data will be uh, weighted. And you can see the summary of the survey design, what information we have in the survey design function. This will tell all the things we have in survey design. So you can see uh, this is giving the probabilities, summary statistics for probability of selecting units, and then different stratum sizes. These are different sizes of different strata, and design primary stage unit and actual primary stage unit, and then primary sampling unit, sorry, and then you have all the variables you have in your data, right? And these are the variables like education and income we have obtained, we have updated last time. So these are the variables. So I think I have saved different demographic variables. If the variables are not saved for safety, we can just rename all these variable, and for easy of our analysis. And then we will perform different statistical analysis. For example, we obtain the survey mean for age and income. You can find survey mean for a single variable or multiple variables that are on quantitative scale. So in this data set, we have just two variables which we are uh, using for our analysis purpose. So age and income were on continuous scale. Income is also even on a categorical uh, shape, like 1 to 15 with 1 to 15 categories, but I'm just for easy of uh, to show you how we can find the averages and standard deviation of two variables. You can just keep income as quantitative, and then just see we will we have mean ages, that is 37.2 years, 37.2 years around, and with standard deviation of 0.22 years, standard, that is standard error. And income is 20, average income is 24.4, and with standard error 0.66. But this interpretation of income is not correct, right? As we are using uh, and the income category says numeric, but this is not true. This is just for exemplification. So we can add different variables, set of different variables here. For example, you can add other variables here. For example, blood pressure and other type of things, quantitative variables in this list, and you will get a table just like this, mean and standard error, right? But we are mostly interested in computing the confidence interval as well, and I, with you can also obtain the standard deviation as separately uh, using this command. This is basically standard deviation, and the above one is the standard error. So you must know the difference between standard deviation and standard error. So these are the standard deviations corresponding to the age and income, right? So the standard deviation divide by under root n, that is basically standard error. So when we divide 22.39 divide by square root of number of observation, you will get the standard error when the sampling is using a simple random sampling, but without replacement. When there is a without replacement sampling, then it will be it will also contain the finite population sampling, fi- finite population correction, that is called FPC. And you can find confidence interval as well, like this. Basically we are just writing the confidence interval with this survey uh, design function, and you can just uh, combine these two things, for example confidence interval and uh, the mean. So you can just write, I think you can write data dot frame, and you are writing survey mean, confidence interval, and survey mean. Let's see what how this function works. So this is the values. This is the set of values you need to present to just display in your publication: mean, standard error, and then confidence interval. So if you have, when you have a lot of variable, you will just open a table and you can just copy paste this table in your Word, and that's all. So you don't need to do anything with this. And finally, we have uh, the coefficient of variation. In most of the cases we need coefficient of variation. The coefficient of variation is basically the uh, what is the coefficient of variation? Coefficient of variation is basically the standard deviation divided by mean. That is the ratio of standard deviation and mean, and it is a relative measure that is unitless, and we can compare different things with respect to coefficient of variation, which series has a consistent uh, which series is more consistent. If we are uh, comparing price of two things, for example, price of wheat and price of for example uh, oil, then we can just compare using coefficient of variation, as it will give a unitless quantity. So you can just see this. These are the coefficient of variation, and if you want to show in percentages, you can just multiply it by 100. And the next thing is the design effect. Design effect is basically the ratio of two variances. Uh, it is used when we have complex survey design and we are basically comparing that how the new design, this complex survey design, is giving the variation as compared to the simple random sampling. So the numerator will be the variance estimated from the complex survey, and the variance denominator will be the variance obtained from simple random sampling. So if the design effect is less than 1, we say that the new sampling scheme, the current sampling scheme we are using is more efficient. Otherwise, the simple random sampling is more efficient. So you can just add a column of design effect for your for each variable you have. You are just for example, for age we are finding the survey mean, and with taking into account the design effect. And similarly, that is 6.63. Basically the sampling design used in this data is more efficient or less efficient than simple random sampling. That is 6.6. Design effect is 6.6, right? As design is the ratio of two variance. In the numerator, the variance estimate for the current sample, including all of its design element, and a hypothetical sample of the same size drawn and SRS. So design effect basically tells how your sample is uh, efficient as compared to your simple random sampling. So this is the ratio of just two variances. So it should be small uh, as much as possible. Then we can say the simple the current sample is uh, uh, more efficient than a simple random sampling. So that's all about the quantitative variables, and you can also find the quantiles like median, Q1, Q2, Q3, and other type of quantiles. You can find, for example, 30th percentile, you can find 70th percentile, we can find 90th percentile. You just need to write the survey quantile function, and then again uh, we are finding for age, and then design, survey design, and we are using basically 25th percent and 50th percent and 75%. Basically we are finding Q1, Q2, and Q3. If you are interested in 70th percentile, then you can just write 70 here instead of 75. So these are the quantiles you can obtain. So uh, these are the quantiles with their standard errors. So these are the things we use to obtain the 5 number summary statistics for a quantitative variable, and hopefully we will learn how to analyze data on qualitative scale using survey weight in our next video. Thank you for watching, and if you have any question related to these computations and the things we discussed in this tutorial, you can just write me in comments. Uh, Thank you and take care.